All right, so here we go. Uh, there we go. Had a good day today in class, despite all the Wi-Fi issues. So you all can see this. This is class 22, which is a lot. Normally it doesn't go past 18. So class 22 for the Mega Packet 2. And I did hit record. All right. So let me go through some of the things we talked about in class. Took the roll. That's for class. That was we did a feast and film in class the Friday, while you guys were taking the test, the Friday before break. That's some pictures from that. This is my Thanksgiving. It's been a good chunk of time stuck in Waco, Texas. But we won't talk about that. We'll talk about it in class, but it's not really something I want to record. A string of profanities. It's not something you want to put on Zoom. Profanity-laced tirade is the phrase for that. Well, I'm kidding, of course. Here's December. Now, Eric asked the question, what is the deal with finals? And in my 35 years, we've never offered this deal to students. First off, though, before we get to finals, for this week, test 2A makeup, which may well be one of you or somebody who's watching this recording, you have until Wednesday. I would not cut it that close, though. If you're going to come, if you're at school, if you're watching this, but you've been gone today and you're watching it, you're going to be at school, okay, then come by and you'll come by at lunch. If you're at home and you're not coming up to school, you only have one choice, I guess, and that is to, I can email you the PDF, you can print it off and then take it and you get an hour and then bring it to me on my porch. Or you can come on my porch and pick up a paper copy, but you gotta let me know first. I'll set it out for you. I'll put it in the bin that has your name on it in the folder. If you don't know, there's a place with your name. And then you'll pick it up. Then it'll be that, or if you don't have a name in a folder like Evan, I don't have your name yet, but I'll put it in the handouts box. So you'll find the test. Take it home, give yourself an hour, take it, and then hand it back in. Okay. But the last chance to do that is Wednesday this week, December 2nd. After that, it's a 0. You can still take it, I suppose, for 50%. All right. Nothing else big going on this week. We do have something due Sunday night, but I'll talk about that later. Now, next week, so here's the deal. Back to what Eric's question was. Eric asked, what is this exemption deal with the finals? Well, in 35 years, we haven't offered this, but we're going to now let you exempt the final in any class, not just one class, any class, if you have an A or a B in that class. I think like on December 9th or December 10th, if you have an A or a B. I'm not sure whether it's the 9th or 10th. Don't quote me on that. So whatever your grades say on the 9th and 10th, if it's an A or a B, you don't have to take the final. So normally my final is, I shouldn't be recording this. Well, somebody watch it, want to know. Okay. So normally my final has packet 3 in it. Or in this case, it's packet 2B, test 2B. But since a lot of people, probably half my kids or 2/3 of my kids won't even be there on the 17th and 18th, I'm going to give the test, the packet 2B part of the test, I'm going to give that on the 16th. Okay. It's like 2A. Like test 1 was 300 points, right? So 2 was split up. So 2A was 150, 2B will be 150. Also on that day, you'll turn in your packet 2, which is huge. It's like 16 pages at least. It might go to 17 or 18 by the time we're done. And that is worth at least 200 points, maybe more, plus a 100-point notes check. But you have 100 points for the notes. So that's about 3 times what you should have had for packet 1. So a lot of stuff is due the 16th of December. And that might be true for other classes too. I apologize, but this is the situation they put us in. Yeah. So if you have an A or a B, if you have an 88%, then I think you probably should take the test. I doubt you're going to drop to a C. You probably won't do that bad. I'm talking about test 1. I'm talking about the finals over packet 1 and packet 2A. See, the test 2B, which is Wednesday, is over about 2.8 to about 216. I'll give you details on that later. We're talking 2-3 weeks from now. So, and then this is over packet 1 test and packet 2A test, which you already had all those. Hall of Famers are exempt from that, but really, it's just pretty much everyone's exempt from that if you're got an A or a B. So that's not a big a deal anymore. Okay. So you will probably your last day will be the 16th, but if you got an 88, 89, 87 maybe. Thing is, it's only 150 points, so it's not like it's going to bump you from I don't even know if it bumped you from an 87 to an 89.5. I don't know if it's enough points to do that. But if you're sitting at an 81, why would you possibly take the chance of dropping down to a C? See what I'm saying? You're not going to get an A. So, yeah, we'll take it on a case-by-case basis, but I'm cool with if you have a 79.5 and you exempt, and you have a 79.5 as of, I think it's the 10th. I think it's this date. If you have a 79.5, then I would just say call it good. Now, that doesn't mean that you won't drop down to a C after this day, after the Wednesday the 16th. Oh, and this also came up. This will be, I'll fix this calendar. But people were asking today, what about black and blue? Okay, so this will be blue, black and blue, black and blue, black and blue. Those will be the 3 black and blue days from test 2A, okay? This all makes perfect sense. Anyway, I'll fix the calendar. I'll beef up the calendar and I'll put that on the cover sheet of the Canvas. Okay, so the only test that everyone has to take is test 2B. Now the take-home test for that will be passed out Tuesday, a week from tomorrow. There'll be a PDF, not passed out. There'll be a PDF available that evening by 8 p.m. And then Wednesday, I'll hand it out in class. And I'll also make it available on the front porch by, I don't know, by 1 p.m. or 1:30 p.m. Wednesday afternoon. Okay? And then if you don't want to print it off, that's the usual 2 pages. And then we'll do a Zoom help for that on Sunday night. I know it's weird, but it'll be a Sunday night Zoom for just that take home. And then we'll submit it Monday the 14th. And then I'll post a video key. So just like we did with 2A, I'll post a video key by 4 p.m. the 15th, and then the test is the 16th. Okay? Everybody does that. Finals, I don't know why they just didn't say just forget finals. But anyway, I'm not going to question them. So after saying all that, who has a question? Let me turn on the chat. I'll turn on the chat, but I don't have enough screens open. Okay, no one's doing chat.
I have a question.
Yes.
So if we have an A and we still want to take the final, could we take the final?
Oh, yeah. I totally respect that. I think it's a good idea to take the final just to kind of see, did you really understand it? And you could do this as well. You could do this. And I have Hall of Famers sometimes that'll take the final just for fun, and they'll put at the top, do not count. So you can take it just for fun and say, do not count, DNC across the top, do not count. And then I'll grade it as a courtesy to you. And I like to see how you're doing too, so it's fine with me. Certainly, 100%. But if you have an A, you probably want to make sure that it doesn't get counted. Now, maybe you have a 91, and then you on that 16th, you know you blew it. You just bombed that test. And you go, uh-oh, I better take that final, see if I can maybe bump my grade up again. So there's different strategies. But good question. Who else? Okay. If you think of something, oh, go ahead, Rose.
Have you graded the test 2A?
Oh, good question. I've graded, I'm on problem 6. I graded one problem at a time. So I have to finish 6 and 7. Now, the reason why I'm not in a huge hurry is because I can't hand those back until these makeup grades until the makeup tests get taken. And I want to give those kids a chance to come in or to get in contact with me to make it up. Now, after Wednesday, I can turn it, I could, the earliest time I could give it back to the classes would be Thursday, but it's probably more like Friday or Monday. I have a bunch of recommendations due this week, and that's taking up all my time. And this, my company, this Ask Me Tutoring, is taking up a lot of time too. So I may not be able to totally finish, but I'm almost done with it. I mean, I'm on question 6 out of 7. And you all are doing pretty well. So anyway, that'll be up. It'll be up because you're going to have it back, obviously, to do black and blue for the 7th, 8th, and 9th. Okay. All right. All good questions. Anybody else got one? Let's keep on going then. Here's this week. Now, it's a pretty normal schedule. We start Girl in the Jeep on the 13th. If you want a head start, you can start Girl in the Jeep anytime you want on the 13th. I mean, on the 2nd, it's 2.13. You can start that anytime you want. I'm looking at what I'm looking at. It's this right here. Work together and assign the rest. So I'll go over a sample problem during the Zoom on Wednesday and in class on Wednesday. And then there's 3 problems I'll assign you. So you might want to wait till I go over the practice problem. And then that is due not till Sunday. It's 24-point assignment, and that's due Sunday at midnight. So that's the only thing that's the only thing you have to submit this week, unless you haven't taken the test. What else we got going? Oh, there are 3 new equation sheets, 2 new equation sheets. This is the old equation sheet, the orange one, you're right, the one you get on tests, and you ought to print these out. They're they're on the Facebook group. You could save that image as a PDF and print it off. I don't have them. I don't think I have them in the PDFs yet. That always lags, but they are the first place they go is the Facebook group. So, which seems to be down today. I don't know what's going on Facebook. Anyway, here's side 2 or page 2. Let's blow this up and look at it. So the first thing on there, I thought you all maybe needed a sample unit analysis, kind of the, just because a lot of students end up taking this to college. They toss their notebook and they toss everything. One thing they keep is the equation sheets. Now you can keep a paper copy of them, or that Facebook group is eternal. That'll never go away as long as Facebook is still a company. You'll have that Facebook group to go back and refer to. Because I'll have kids from 5 years ago that'll go back and look at the Facebook group. Sometimes they message me or they make some comment on that Facebook group from 5 years ago. That's fine. That's your archive of what happened in class. All right, and then the next thing on that sheet, these are the pre-orange equations. And then there's the first, second, and third orange. Now today, we're going to derive the third orange. We're going to derive that equation today. And then there's CL-DEPA, how to work a physics problem. And the next equation sheet looks like this. The one I had, if you've seen these, I posted them on Facebook over Thanksgiving, but I'd screwed up on it. These are examples of working problems using the orange kinematics, using the CL-DEPA method. So this example 5 here, the one on top, that uses the second orange to solve a problem. Then this is the one that I screwed up on. I just fixed it about 15 minutes ago. Number 6, example 6, and this is using the third orange, which we're going to talk about here in a minute. We're going to derive. And then the next one, the next is more of a challenging problem. This is using the second orange, but requires the quadratic formula to solve it. But that is something we're actually not going to get to probably until next week. So you can look at it if you want, but we'll deal with that later. That is the orange version of the quadratic formula. We'll show you this later. Don't worry about it. Anyway, those are 3 new equation sheets that I thought might help you. And the last thing I want to talk about in announcements is we, for seniors, some of you may be seniors. I don't know. Any of you guys seniors? Speak up if you're a senior. If you're not a senior, this is not for you. But we're also going to do this for juniors in February and for sophomores in like May-ish, March or something, probably March. Yeah. Probably sophomores in February, early February, and then, sorry, juniors early February, and then sophomores probably mid-March or something, around spring break, or I don't know. So we used to be called Study Zombie, but it's this company me and another guy run, and it's for all kinds of stuff, but we're still testing like ACT prep, SAT prep, PSAT prep. We're going to we're going to do GREs, we're going to do MCATs, we're going to do all kinds of stuff, LSATs even in the future. But for now, we're just ACT. And we're also going to do, like, we'll do 6 packs and 12 packs in the summer of classes. Like last night, I just got an astronomer. He's an excellent astronomy professor. And he's agreed to do a 6-pack at least this summer. So these are all they're like mini courses, and they're like review sessions. And that's this company I've started. It's called Ask Me Tutoring. If you go to the www.askmetutoring, you can sign up, but this is only for seniors in December. Okay. Anyway, more about that later as more come up. But if you're a senior, you probably already got an email. Okay. And then we did Joke Monday. That was Nate Bargese. He's pretty funny. But I can't really show it to you because they don't show up on these things. Okay. So when I was putting together, I'm starting to put together problems for the upcoming take-home test 2B. And when I have documents of lots of questions I've written over the years, and I noticed that there's questions. Some of these questions will be coming up, but I noticed there's questions that I wrote that never made it onto a test this semester. So I thought, well, we'll go back and pick up a few of those. All right, so get out your paper, pencil, your notes. This is a good one for your notes. You at home, you guys are all at home, but you all should be keeping a little notebook. I know Miranda is, I know, Sophia, I know you guys are, but that's what you're going to turn in. So this is something that should go on that notebook, okay? Something that should go in that notebook. And I'll put the screenshot up on it, but this is a test problem that I've given on tests over the last few years. This test problem came from the University of Texas. Basil alum. Basil was one of these famous Norman High students. There's a whole Basil story I'll tell someday, but Basil, now he's a petroleum engineer. He works all over the world with Chevron, but makes a lot of money. But anyway, Basil went to the University of Texas, and he would send me like what he thought, because he was taking physics for engineers there. And that's a top level engineering school in the country, one of the top. It's really hard to get into. But if he found a good problem that he thought I might like, he'd send it to me. Well, here's one of the problems he sent to me from University of Texas. So I thought, well, you guys should have a taste of a typical, college kind of university problem. And I have others that I got from Princeton, from a guy named Marin Nitzoff. When he went to Princeton, he would send me physics problems. Well, here we go. This could have been on the last test, but ran out of room. It might still, a modification of this one might be on the take-home test or on test 2B. All right, so see if you can read this. I don't know if you're looking on a phone, you probably have a hard time reading it. But, so I'll kind of read it to you. 5 motion diagrams in which points represent the positions of an object at equal time intervals are shown below. Which statement is correct? Okay, so first off, students are always asking, what the heck? But I thought this was a clever way of showing acceleration and negative acceleration. This is like if I had a strobe light, and I used to use a strobe light in class. I would do demonstrations with strobe lights because you can see motion, like projectile motion. You can do it on streams of water and see how the water is really particles. It's really cool. The problem is, not in my class, but a student, when it had an epileptic seizure with a strobe light. So Normal Public Schools said no more strobe lights. Anywho, if this is like a strobe light on a particle moving along. So like in A, it's a particle that, as you can tell. So like, let's keep it simple. And let's say that every second you're seeing that particle, okay? So like in A, what's happening?
You're seeing it like less and less.
You're seeing the particle, but every time you see it, remember, every one of these little dots, circles, represent the particle at a second. So this is, let's go ahead and just say, just for instance, this is 0 time, this is 1 second, this is 2 seconds, this is 3 seconds, okay, et cetera, et cetera. Same thing here, 1, 0, 1, 2, 3, 0, 1, 2, 3. So can you see, so how would you describe the motion of the marble, let's say? How would you describe the motion of the marble in A? What's happening to it?
It's accelerating.
Yeah, it's accelerating, right? Because it's covering more. I mean, we're diagnosing this problem. This is, delta x, whatever, 4. This is delta x 5. This is delta x 6. And so you can tell that it's growing and growing and growing in that same amount of time. All right. So yes, the marble in A is accelerating. What's happening to B? Before we look at the questions, before we even look at the choices, look at each one of these. Let's kind of think about what each one's doing. What's happening to B?
Accelerating, then slowing down.
Right, so it's speeding up. It reaches a maximum speed. It looks like about right here, and then it starts to slow down again. What about C?
It's constant.
Constant velocity. And is it moving fast or slow?
Fast.
You might think so, but its delta x is tiny. So it's like 1 meter per second, 1 meter per second, 1 meter per second. Whereas in A, it started off 1 meter a second, then it went to 2 meters a second, then went to 3 meters a second, then went to 4 meters a second. See what I'm saying? So C remained slow. D is also accelerating. And E, what's E doing?
It starts fast and then slows down.
Right, so it's accelerating as well, only it's negative acceleration. If we consider on your screen, you're looking at it, left to right, if we consider that the positive direction, then the acceleration vector is what we call retarding the motion. You're not supposed to say the word retarded anymore, but in physics you say it because it's retarding the motion, meaning that it's slowing down it's acting as a force against motion, like it's something going in the wind or something. Okay. So, and then a student in class said it was decelerating, and I chided them because you can't. Deceleration is not a term that any respected physicist would use. It's a layman's term, but deceleration gets you in real trouble when you start using that term. Better to say negative acceleration. And I'll show it to you later why that is. All right. So now that we've already kind of described these, now we go through the answers real quick. A says C has the greatest speed and no acceleration. We've already established that C is going the slowest. So no, that's false. So we can mark that out. No. B says D speeds up then slows down. Is that what's happening?
No.
No, D is actually just continues to speed up. So that ain't it. It's half right. C says B ends with a small negative acceleration.
Yeah.
Okay, so C looks correct. Let's double check. D says A is accelerating faster than D. Well, they're both accelerating, but look at this. On D, by the time you get to the fourth second on D, I'm right here. The fourth second of A, I'm right here. So D is much faster accelerating than A. And finally, E says E has the lowest average speed. And some students jump on that because they say, well, it's a negative acceleration, but speed is absolute value of velocity, but it's average. Remember, if there's acceleration involved, average acceleration V bar equals V naught plus V final divided by 2. Well, the V naught of E it went this pretty good distance. It was the fastest one out of the chute. In the first second, it was all the way out to here. So it started going the fastest of all of these, and then it went slowed down, but its average velocity is still greater than C. I mean, C never had a very good velocity. Now, a question I asked them in class, I said, which of these, A, B, C, D, or E, is represented by the red duet? What say you? Let's say Takaki or somebody who has not answered yet. Miranda or Evan or Eric, maybe. I don't think Eric's said anything. What do you guys think? Which one of these 5? Remember, we have the orange trio, we have the red duet. Those are really the only 2 we're working with so far. Which one of these would be represented by the red duet?
C.
C is correct, because that's good. So I'm giving you a zoom point. Because when I ask you a specific question, anybody who's answered so far, give yourself a zoom point. I'm going to give Eric a zoom point. If I call you out and you answer, let's make a new rule up. If I call you out on Zoom and you answer, you're on the spot. I say I call 2 people out and you're the one that answers. You get two, count them, 2 Zoom points. I'm being recorded. Yep. Okay, so I said it. So you're right. C is, in C's case, that's the only one in which there's no acceleration, which means that there is velocity. I mean, it's not a solo. There's velocity, but there's no change in velocity. So therefore, it'd be a red duet, not an orange trio. Okay, well, we've milked that problem for all I can get out of it. Now that I've spent so much time on it, you can probably expect to see it probably in the take-home and on the test. Will be like the University of Texas. Okay, this is a look back. We did this, I think, on Tuesday of the week before Thanksgiving. And this was the derivation of the second orange. And then we did a problem over here where we first learned CL-DEPA. And then on Wednesday, we did on this Zoom, we did a couple of problems using the second orange equation. Okay, now today, we're going to go back to 211 and we're going to derive the third orange. Yeah, we're going to derive the third orange, then we'll work a problem, then I'll give you a little homework, and then we'll call her good. Okay, So I'm hanging the third orange in the room. I guess I'll do it tomorrow morning. What the heck? Okay, back to this. I'm hanging the third orange in the room. So I'm just going to write it down for you guys. In the box on 211, this is the third orange. It's V final squared equals V naught squared plus 2A delta X. So write that down in the box. Now we have an advantage over Max Planck and Isaac Newton and Albert Einstein in that we know where we're going. They were just putting down combinations using algebra and calculus and geometry, as well as some empirical data, and then developing equations, developing relationships. We know the relationship, but I'm trying to get the whole purpose to this is to get you to start thinking in the same neural pathways as the great thinkers did. Okay, so we've got to start somewhere. And okay, hold on a minute. You're right here. Let's go. Okay, here we go. So looking at these equations, now there are the pre-orange, and we're going to use those in this derivation. But looking at these equations, obviously ignoring the third, okay, that's not, we're trying to derive it. So looking at the first or second equation, which one do you think we should start with to derive the third?
Second.
If I do the second, if I start with the second, the problem there is, if you look at the third, well, okay, let's just look at the third. Sorry, erase all that. Looking at the third equation, I'm not saying you couldn't start with the second equation because it has a delta x. I see what you're saying. And there's some advantages there. It has a V naught. It has an A. So you go, well, that sounds pretty good. But I'm going to contend that the better one to start with is the first. And the reason being that, look, V final's already isolated. It has a V naught, and the V naught's about where it should be, right? It has an A, and that's about where it should be. The only problem is that it has a T. I'm sorry, it should be green. I want to kill the T. I can't just kill it. I got to replace it with something. So I'm not saying you couldn't go home, or you're home, but you couldn't sit there on your own and start with a second and still have success through substitutions. But over the years, I think the better one is to start with the first. Somebody might try start with the second and prove me wrong. Okay. Maybe you could. I don't know. So now let's go ahead. I'm going to start with the first. And so we have V naught, so we have V final equals, equal sign there, V naught plus AT. And I say, man, this is going to be one or two steps, because all I've got to do is I've got to get the T out of there and replace it with something involving delta X. Okay, and the reason is it's just an intro. Remember the only choices we have are intro, iso, sub, or rearrange. Those are the four we use. Keep it simple. Well, what's my next move? I've got to get rid of the T, and so I want something that'll get rid of the T and bring in a delta X. And
So the second orange equation?
Yes, so that was been suggested in every class today. I should move this around. Hold on. Let me move this. I don't have to keep going all the way back. Okay, stick this right there. All right, now, done. Now, if I go to the second, and I'm not saying you couldn't do it, because the second, you go, hey, look, there's my delta X. Yes, but you're introducing a lot of pain. You're introducing, along with the baggage that comes with this, is you're getting a t squared, you got a t in there. Oh my goodness. So yeah, you brought in the delta x, but you brought a lot of problems with it. So I think another option is that one. So let's just use that one. And I'll introduce that. It's legal. So here we go. See, if you're thinking about it, you know, then that's good because you're putting in, all right, so this is V bar equals delta x over t. So you need to be an active learner. It's hard to do when you're watching your computer screen, but start working along with me and then you can ask questions. We're a small enough crowd where you don't need to chat because I don't get to chat enough. And that's another intro. Just shout it out when you got a question. Be brave. Well, now it looks like what we're going to do is the next step is to isolate the t, right? So we can substitute in. So go ahead and do that. I'll give you a minute. So in other words, you're going to have, your next step is going to be t equals something. And you tell me what goes there. And this will be a sub. No, this will be an iso. It's an isolate. So the reason why I'm pausing here is that grading the last test, I noticed that there's still about 10 students out of the 81 that, about a dozen, that still struggle with isolating a variable. And I know at one point in your life you knew how to do it, but you've forgotten. So it's worth it to practice, you know, isolating a variable. So in this case, we multiply both sides by t. Since this is a tape and you're not the only ones watching this, you have a better color scheme here. Go purple. Multiply both sides by t. And then, right, I'm trying to get t by itself, and then divide both sides by v bar. V bar, t is t over 1. Then divide both sides by v bar. I'm kind of doing what's happening in my head. So you end up with t then equals delta x. Oh, back to orange. Delta x over v bar. Okay, so if that looked like magic to you, you need to brush up on your isolating variables. All right. Well, I could right now, and I have in the past, I could substitute in this. I could substitute that in for that, but I'm going to wait. I'm going to hold off. That's a messy thing. In other words, I don't, yes, so that's great in that you get your delta x, but you don't gain much because you add a v bar. You got rid of the t, you brought in delta x, but then here comes that average velocity again, which nobody wants. And so we got to get rid of it. And so I'm going to go and get rid of it before I substitute it in. So let me kill that. All right. So we need another equation for v bar. And can somebody take a look? Which one should we use? Looking back at your equation sheet. You should always have that handy. If you have a notebook, really you should print those off and tape them in. So you can keep like at homework, you keep flipping back to it. It'll be a really nice archive because eventually it gets like 20 sheets. You're trying to remember formulas from back in, November when it's sitting there in April. All right, so v bar equals, give me that equation.
V naught plus, oh,
You got it.
You can go ahead.
oh, thank you. V naught plus V T over 2.
V
Or
final,
V final.
yeah, over 2. All right, so there's my intro. And then it's already isolated. Okay, so now, so now I'm just going to substitute it in. So sub, and the sub is t now equals, and this gets messy here, t now equals delta x over v naught plus v final over 2. Good grief, this whole thing's getting messy. And you know what? I don't like that. In fact, ACT is coming up, and ACT will give you double deckers. It's called a double decker fraction. And like early on, like in the first 10 problems, they'll have a double decker fraction in there, and they'll want you to simplify it. And so, what would this one be simplified? In other words, get rid of the double decker. In other words, if I said, if I asked you, what is this? 1/1/3, what's that equal?
1/3.
Well, it's 1/1/3.
Wouldn't it be 3?
Yeah, because it's the inverse of 1/3, right? So if I asked you what's the inverse of 1/3, you'd say 3. And that's what that's saying mathematically. So that's 3. So it's sort of the same thing here. See, you brought that 3 up top. Well, you bring the 2 up top. Okay. And so this becomes, and I'll make this another step, I guess. So this becomes T equals 2 delta X over V naught plus V final. Okay. I finally got it down to, I better erase that. They're going to think that means something. I finally got it down to where I feel comfortable now substituting that in. So I'm going to highlight that. You got to be courteous to your reader. Okay. A good physicist always explains their work, and they're kind to their students. Trust me, I've had bad physicists as professors and teachers, and they don't explain their work. It's like some power trip. All right. Well, you should know that. Unfortunately, I've had way too many of those. You'll run across them. You know the solution to that? Keep pestering them with questions. If they get mad, go to the dean. Okay, so now the substitution. So now let's rewrite it with the substitution. V final equals V naught plus 2A delta X over V naught plus V final. And you go, man, wait a minute. This thing started off so easy. All I had to do was that stinking T. I had to get rid of that T and put it in terms of delta X, and it's becoming a nightmare. Okay, so we're almost there though. Well, now the good news is, okay, that was sub. No, that was rearrange. And this is essentially sub. Okay. So the good news is that our party is set now. Look at all the characters. We wanted a V final, we got a V final. V final is the host. V final wanted a V naught, yes. Got an A and got a delta X. There's no T in there to ruin anything. No stupid V bar who is boring and loud and obnoxious. Nobody likes V bar. So we got the people we want. But the problem is they need to be rearranged so it looks like, so this equation looks like this equation. This equation looks like this equation. Okay, now the next move, my first year teaching physics, I multiplied both sides by V naught plus V final and distributed, okay? And that, I'm not saying it doesn't work, and I'll accept that, but there's a smarter way. There's a more beautiful way of solving it. This is like, doing these derivations is like poetry. Not really. I mean, it's like really bad poetry. Algebra derivations are kind of cool, but they're also kind of boring, and they're not as exciting or as interesting as a calculus derivation. You'll do some calculus derivations in AP physics, and those can be beautiful. Arik Ozma, who's now at Oxford, getting a PhD in economics, I think. He went to MIT for a while, now he's over at Oxford. But when he was in my class, in my AP physics class, he'd kind of work ahead of me a lot. but we were doing a derivation and he started working on his own and then kind of put his head down on the table after a while and had finished before we finished because I was going on and on, you know. And so he'd finished and I thought, he looked like he's sick. I thought, are you okay? He said, no, 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 no. I said, I'm fine, I'm fine. He kind of brought his head up. His eyes are kind of watering. I said, wow, what, are you okay? I mean, did something happen? You hear some bad news or something? He goes, no, no, no. He said, I said, I did it myself. I derived it myself, my own way, for the first time in my life. I used my knowledge and I used calculus. And he said, it was like mind blowing. He told me after class that it was mind blowing because I all of a sudden thought, and he said, now I know what you mean by poetry. It's like, it's amazing. So unfortunately, we don't do a lot with calculus in this class. Now in AP you will, and hopefully you'll have experience like Arya. Well, we're going to do something that's the next best thing, and that is using a identity from algebra. And algebra is made by the Persians. It's beautiful too. It's beautiful logic. And I'm going to do something weird you wouldn't expect me to do. I'm going to subtract V naught from both sides. It's sort of like in that movie, The Queen's Gambit. You know, sometimes you do something, you make a move, and it's like you sacrifice your queen, which seems bizarre, but then they go for it, and then you destroy them. And that's sort of what's happening. You make this weird move that nobody would go, why are you doing that? V final minus V naught equals 2a delta x over, I'm going to rearrange this one as well. V final plus V naught. B plus A is A plus B. Okay, so now that's equal. Now, anybody know the next move?
Multiply by V final plus V naught.
Multiply both sides, right? So now let's go. I think I know where you're going. So now we have V final minus V naught times V final plus V naught equals 2a delta x. Now what do I do?
Divide both sides by V final minus V naught. Or wait, no, not that.
That wouldn't help, right? Now you could FOIL it, okay? You know, remember FOIL, first, outer, inner, last? But this is an identity. Now let's pause for a second. Let's go back, let's go to the ACT. Let me pause. Hold that thought. Here's a problem from a fairly recent ACT in the last 5 years. Now look at this problem. I didn't show this to class today. I told them I'd show them tomorrow, but I'm going to show you guys today. And this is from an actual ACT. And it says, which of the following is a factored form of the expression 36x squared minus 49y to the 12th? Anybody got the answer? And I can promise you, this problem will be on the ACT in some form or fashion. I've seen this kind of identity used 3 times on one ACT. I saw it used 3 times. Once in the algebra section, once in the complex numbers, and once in the trig section.
Is G the answer?
G isn't the answer. What I'm saying is, if you don't know this identity, you're going to have a 20% chance of getting the answer right.
Is it H?
H. Let's take a look. Now, this comes up with, here's the next slide. This is from a slideshow I do when I used to do the ACT. That you first recognize this as this will be on your ACT. So it's on the SATs too, but not as much. This is a square, right? This is a square. They're perfect squares, and it's a difference of squares. And so from algebra, you may have forgot this, but from algebra, there is a formula, a squared minus b squared equals, not c squared, as the class shouted out today. It's the a squared, that's a squared plus b squared equals c squared. That's Pythagorean's theorem. We're not talking Pythagorean's theorem. A squared minus b squared equals a plus b times a minus b. Okay. Now, if you know that, and whoever said H gets the zoom point, because they must have recognized that this is a perfect set of, it's a difference of perfect squares. And then when you take the square root of each, look at the next slide, you end up with that. You can look at this and go, okay, and then it's obvious that the square root of 36x squared is 6x. That's as far as I got to go. I mean, if I'm taking the ACT, I've taken the thing, I've probably taken 100 ACTs in my life, just practicing for my presentation. And I would see this and go, okay, I know what kind of problem it is. I look at this first one, I see that's a perfect square. I go right to here and say H. And so that problem takes me about 5 seconds. Whereas if you did not know that identity, you would spend a minute or two on this problem and still not get it right and still be guessing. Okay, so word of the wise, know that formula going into the ACT. So back in our problem, this is the reverse. We have the factor. Now we got to do is go ahead and do it as a difference of squares. V final squared minus V naught squared equals 2A delta X. And now you can see that's all rearranged, by the way. RE, RE, RE. RE, RE, RE. Okay. Everything else is RE. And now you can see that all I did at that point was just add V naught squared to both sides, and I have my equation. Okay, whoo, derived. That was a much harder than we thought it was going to be, or I thought it was going to be, right? Or I knew it was going to be harder. Let me clean this up a little bit. That should have been, I should have shown that going there. Oh, this is the one that's going to get the screenshots. So, okay, good. Now let's quickly do 2 and 3. Question 2 says, and then we're done. Question 2 says, so when would you need to use the third orange equation? What do you say? What situation will we need the third equation with? When you don't know blank.
The V final.
Oh, true. I don't know V final, but
Time.
yeah, there's no time. I mean, I'm trying to find V final. There is no time involved, so you don't know time. And I'm not saying you're wrong. You obviously don't know V final. Okay, so when you don't know what T is, like if T is not given to the problem, you go, okay, third orange. So now let's look at this. This is already set up for you. T is not given to the problem. So let's knock this problem out, and then we'll call her. Problem 4 will be homework, and then that'll be it. Here we go. So blah, 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 blah. And finally it says, it's quitting time. He hops in his Pilot and floors it. That Pilot's in the junkyard now. We gave it to Cars for Kids, so I'm assuming it's in the junkyard. What will be the final velocity? So we're trying to find V final in kilometers per hour, okay, after he's accelerated. So there's my A, 4, and there's my delta X. So the drawing is pretty simple. We still said required, so we're going to do it. Car going along. I'm getting you warmed up for doing free body diagrams, which is our drawings you always have to do. And now what's V naught?
Zero.
Yeah, it didn't. You have to assume he's in his parking lot, right? He's in his parking space, so you have to assume V naught is 0. V final I'm trying to find. Delta X here is 16 meters. And I'll be lazy. A is that. Okay, that's good enough for a drawing. Well, you CLDPA, you got to write the equation. You get points for this kind of stuff. So I say, okay, V final squared equals V naught squared plus 2A delta X. Now, if I want to test and I'm just kind of in a hurry, I said, well, at least I got some points. I'm going to move on, or maybe I would, or maybe I wouldn't. But at least I've got now I've got the points for the drawing and I've got points for the equation. So if this is a 20-point problem, I probably have like 8 points already. Well, the V is already isolated. What break do I catch here on my equation? What break do I get here?
You can just multiply 0 by 0 since it's a V naught.
Yeah, in other words, V naught is 0. So I'm just going to kill.
Yeah, you can just
I'll bring,
cancel it.
yeah, I'll bring my green kill pin out and I'll kill that. That's 0. Okay, so now I'm trying to find V final. So I'm going to scroot both sides. So V final then equals the square root of 2a delta x. Now, if I box that in, that's the CLD, but that's the isolate variable. And now if this thing's worth 20 points, I got probably 14. I got 14 now out of 20. And a lot of times, like on the AP exam, on the AP physics exam, you'll have, and I hope you take it. You guys aren't seniors, I don't think. If you're juniors or sophomores, you should take AP physics next year and then take the AP physics exam, because that is the most doable exam, except for maybe AP English. I think AP physics is the most, mechanics is the most doable exam, and you get 4 hours of college credit, up to 4 hours of college credit. Save a lot of money. And
Do
if
you
you
teach AP physics?
what?
Do you teach AP physics?
I taught it for 15 years, but now Mr. Pentecost teaches it. I don't know what's going to happen next year. He may be in Africa, so I may be teaching it again next year. I don't know. We'll just see what our numbers are like. So I may end up teaching it next year. But if I do, I emphasize, like, we look at a lot of AP physics problems so that when you get there in May, you take it, you go, oh man, I know this stuff. And normally kids get 4s, 3s and 4s, some 5s. So they do pretty well because you've had 2 years of physics, you know. It's only okay, to get up to 4 hours credit in college, I'm talking engineering physics credit, you know, not this physics for poets crap. I'm talking engineering physics. This is calculus based. But you only have to do 35 questions, multiple choice, 35 multiple choice questions and 3 free response. That's it. It takes you an hour and a half. And boom, in an hour and a half, you've saved a lot of money. Well, enough of that. So, but Mr. Pentecost has had good success too with his students, and Dr. Peck did as well. So I'm gonna, because I see I got some unit issues, I'm gonna go ahead and do a little unit analysis dipsy do in here. It's not full-fledged gold standard, but I see I do have some issues coming up. So 2, I'm trying to end up with kilometers per hour. Kilometers per hour is where I want to be. That means under the radical, I've got to end up with kilometers squared per hour squared. And that's, students don't realize that. Inside the radical, that has to be your units. So that's what I'm going for. Kilometers squared over hour squared. Okay, let's put the acceleration in there. So it says it's 0.5 kilometers. And here's a mistake students made on the test, on test 2A. Like, they would put something like this, kilometers per hour per second over 1. That's illegal. I wrote that, illegal. You can't do that. Now, you still could have got the problem right. And in that case, you only lost a couple points. But you can't have fractional units inside a cell. Okay, and this is called a cell, inside a cell here. The whole thing's called a slot, but this is called a cell. Cell over a cell makes a slot. So I've got to write this correctly. You can multiply units, but you can't divide it. So instead, you can write this as, let me erase all that. You can write this as, well, I promise we're almost done. You can write this as 0.5 kilometers over hour dot seconds. And that always irritates students, but yes, you can prove it to yourself. It is true. You can do it. Math's a weird thing. Okay, now that was the hard part. Then we throw in delta x, that's easy. Good old 16 meters over 1. Okay, now what?
60 seconds over an
60
hour.
seconds in a minute, but the one let's just combine them and say 3,600 seconds in an hour. I don't normally like you to combine things, but that's so common. Let's just do it. So an hour, but I don't want to get rid of hours, right? I want hours on bottom. And so like you said, we'll put 3,600 seconds over an hour. Now I bring out the green kill pin. I can kill my seconds. The green kill pin also saves the hours. There's an hour. I want to save those. I want to save that kilometer. In fact, I need another kilometer. So now what?
So 1,000 kilometers over 1 meter.
Uh-oh.
100, I mean.
Uh-oh. Almost. You made this mistake that everybody makes. It's 1,000 meters in a kilometer. So that would have made your answer off by 1,000,000 times. But everybody does it. I do it sometimes. Yeah, 1,000 meters in a kilometer. And then I kill my meters and kilometers. So now kilometers are squared, hours are squared, multiply your numbers, and you'll have your answer. I don't know what the answer is. The answer at the bottom, maybe? Is the answer on about? Yes. Okay, it says the answer should be 127. What? Whoa, I go that fast. Oops. I think that must be wrong. I must have forgot to square root it. There's no way it's that big. Okay, now I'm questioning myself. Daggone it. This is a fairly new worksheet. I think that's wrong. I think that answer there is wrong. Let's look. Now I got to do it. Get my calculator. Okay, you get a calculator too. Now to save time, see this 10 to the third, that's 1,000, that's 36. I'm just gonna call this 3.6. I'll go ahead and divide it in my head. So essentially I'm saying 2 times 5 times 16 times 3.6 equals, oh my goodness, I messed up. 576. Is that what you're getting? Kilometers squared over hours squared.
Why would the 3,600 be reduced to 3.6?
Because on bottom I have 1,000. See, I have 1,000 there, 1,000 meters. And so I just took that 1,000 and divided it into 3,600 just to save me time. In other words, I got rid of the powers. I get rid of exponential powers before I even do anything because they just clog up my calculator. So did anybody else get a 570? We get the square root of that. My answer is dead wrong. Daggone it. That means I got to change a bunch of stuff. Square root 24. That seems more reasonable. 24 kilometers per hour. Anybody else get that? Can I get a amen on that?
I don't know how you got 576 because I got 57.6.
Oh, maybe I'm wrong.
That's also what I got.
Son of a. Okay, hold on. Okay, 2 times a half is 1. So I don't know where that. 16 times 3.6. Oh, you're right. Daggone it. And now divide that. 7.5. 7.6. Is that what you got? Okay.
Yeah.
A cacophony of mistakes. 7 point. See what I mean by making mistakes? I make them all the time. Kilometers per hour. 57.6. Okay. So after all that messing around in 16 meters, I'm finally got up to 7.6 miles an hour. And this is, I have no idea where that gobbledygook came from. I think I changed the problem and then forgot to change the answer. That makes me worried about 4 as well. But Let me look at 4 real quick. 4 is homework. I think 4 is probably right. Yeah. All right. So 4, I'm going to assign that as homework tonight. We'll talk about it tomorrow, or I'll show you the answer anyway. Tomorrow in class, I'm going to go around and give them points if they did for a point or two. No big deal. Okay. So don't worry about 5 yet. We'll worry about that tomorrow. I got to go back and change all that. Oh man, that's about 30 minutes of work right there. Stupid. Because I got to change it everywhere. All right. Oh, so let me turn this off. Stop the sharing. Okay. Well, that was good. I'm depressed now, but any other, I mean, come on, it's not really that big of the world. This time we're in America. I shouldn't be too concerned about that. But anyway, I don't like screwing up. Because now my kids are going to take that, they're going to do homework tonight. They're going to think they're wrong. Oh, wonderful. Hope they watch this. Any questions before we call it a day? We'll meet. We got 3 more meetings this week. 4, that's 7, 8, about 8 or 9 more meetings, and that's it for till Christmas. Oh, we'll do a Zoom on Sunday nights. That's probably 10 more Zooms or so. All right. Well, thank you all for being a part of this, and you all stuck it out to the end. No one dropped off. That's cool. It's okay if you did. But any last minute, let me turn off the recording now.